Hello children, today we are going to discuss the following topics of motion chapter. The first one is the distance time graphs. So under the distance time graph we have the three cases. We have the three cases under the distance time graph. First one is the distance time graph for uniform speed or for uniform motion. Second, the distance time graph or the position time graph for the uniform speed or for the uniform motion. And the third case is when object is at rest or stationary. So let us discuss these three cases one by one. So move on to the next slide. Distance time graph. First we need to understand what is the distance time graph and for what purpose we need to use it. Distance time graph is used to represent the change in the position when the object changes its position with respect to the time. So this change in the position of the object with respect to the time can be represented by using the distance time graph. So in the distance time graph it is actually a Cartesian coordinate system which is the two which states that there are two mutually perpendicular axes. One is distance and another is the time, or one is the y-axis and another is the x-axis, and when they intersect at a point, that common point is called origin. So in this graph we are taking the time along the x-axis, that is horizontal line shown in the graph, and the distance is represented by taking the distance along the y-axis, which is represented by the perpendicular line as shown in the graph. So this is all about the distance time graph. So now after this we are going to discuss what will be the nature of the distance time graph for the uniform speed, that is the first case. So just focus on this graph. Object has the uniform motion, or when it moves with the uniform speed, then the nature of the graph is shown in the figure, that is a straight line which divides this quadrant of the graph into two equal halves. It's a straight line which also passes through the origin. So when we get this straight line which passes through the origin, it shows that object moves with uniform speed. And uniform speed means the equal distances which the object covers in equal intervals of time. That means the distance is directly proportional to the time, and when any two quantities which are directly proportional to each other, the graph is a straight line which divides this quadrant into two equal halves, as well as it passes through the origin. So this is the nature of the distance time graph for the uniform motion or for the uniform speed. Next is what is the importance of this graph. As it is shown in this graph, the distance time graph, you just focus on the straight line where I showed you the 2 points, point A and point B. So from point B you draw a line which is parallel to the distance axis downwards toward the time, and from point A draw a line towards C parallel to the time axis. So when you draw these lines, they at a point, that is C, they intersect at each other at a point C in order to form the right angle triangle. So B got the right angle triangle A, B and C, and there is an angle between AB line and the AC line. This angle in physics is called the slope of the graph, and the slope of the graph is simple division between the BC upon AC. And if you divide the BC, that is in front of BC there is a distance, and in front of AC there is a time. So if you divide BC upon AC, it gives you the speed is equal to S2 minus S1 divided by T2 minus T1. I repeat again, because there is an angle between AB and the AC line, so that angle is called the slope of the graph, and the slope of the graph is given by BC divided by AC, that is BC is distance and the AC is the time. So distance upon time is also equal to speed. It means we conclude that the slope of the distance time graph gives us the value of the speed from this graph. So that is the importance of this graph. The second case of the position time graph or the distance time graph is when object has non-uniform motion or it moves with the non-uniform speed. So let's see the two columns in the table. One column left side represents the different values of the times, and the right side column is giving you the distance in meter. So in this case, the time, you look at the values of time. So here the time is representing the equal intervals of time, but the distances are not equal. So if you plot these values of time and the distances in the graph, and the graph comes out after this like what I showed you in the picture. So for 0, when the time is 0, the distance covered by the object is 0. See the table. For time 2 seconds it is 1 meter, for 4 it is 4, for 6 it is 9, for 8 it is 16, for 10 it is 25, and for the 12 it is 36. The point which you note down here, the time here is the equal intervals of time, like 0, 2, 4, 6, 8, equal intervals of time, but the distances are not equal. So when object covers unequal distances like 0, 1, 4, 9 and so on 60 meters, it means when object covers unequal distances in equal intervals of the time, the graph is shown like in this picture. So if you plot all the points on the graph, then we get the graph like a curve which moves upward. This shows that the object has non-uniform motion, or object moves with a non-uniform speed. And the last is, when object is at rest, then the distance time graph is a straight line, but that straight line is parallel to the time axis. So this is all about the distance time graphs for uniform speed, for non-uniform speed, and for the object at rest. Next is velocity time graph. So velocity time graph, as I taught you in the distance time graph, we are using the same mutual perpendicular axis. Along the y-axis the velocity is taken, along the x-axis the time is taken. So velocity time graph, it is a graph between the velocity and the time. So the first case of the velocity time graph is when the object has uniform velocity, or when the object has constant velocity. Then what would be the nature of the graph? So when the object has constant velocity, or the uniform speed, or the uniform velocity, then the graph is a straight line which is shown in the solid line in the graph. The graph is a straight line which is parallel to the time axis. So this represents the object moves with the constant speed. In this case, the graph is a straight line which is parallel to the x-axis, and this velocity time graph shows that the car moves with the uniform velocity of 40 km/h. So that's all about today's lecture. Thank you.